Section 2.2 homework deals with vertical and horizontal shifts of graphs. I suggest that you look at problems 1 through 66 so that you can get a good feel for this topic. Do this in addition to the problems that are in my math lab. And certainly you don't have to look at every single one of these problems, but my math lab quite honestly doesn't go as extensively as it needs to go here. And maybe you want to look at every other odd problem. Okay? So let's take a look at the first section, which is to write the equation that results in the desired translation. Looking at number 2. Number 2 says to write an equation that represents the cubing function shifted 2 units downward. And so remember that if we have to shift downward 2 units, that is what we call an outside change, or it affects the y values. So that would be x cubed minus 2. Remember that f of x plus c, where c is positive, is going to be up c units. F of x minus c is down c units. Okay. Now what about number 6, which is to do the absolute value function shifted 3 units to the left? Well, to shift right or left is an interchange, right? Do you remember that if it's an x plus c inside, that's going to shift left c units. X minus c inside is going to be right c units. So if I want to shift 3 units to the left, I've got to make an interchange to that inside of the absolute value. So it would be y is equal to the absolute value of x plus 3. And you can confirm these by graphing. If you graph the basic function and you graph the shifted function on your calculator, you should see that you get the desired result. Now, number 14, 15, and 16 is kind of running off my page here, but it is to match the equation that's given here with the correct graph. So 14, 15, or 16 we're matching to either A, B, or C. So y is equal to absolute value of x plus 4. That's that outside change. Plus 4 means we're going to take the absolute value function and shift it up 4 units. Well, remember that the absolute value function is that V-shaped graph through the origin. So if we shift the origin up 4 units, we would have the point 0, 4 as our new vertex. So it just so happens that part A corresponds to the graph of number 14. Now 15, y is equal to absolute value of x plus 4 minus 3. Well, plus 4 is a shift left 4, minus 3 is going down 3. So again, what is going left 4 and down 3? That's every point that's on the basic absolute value function. A key point is 0, 0. So if we shift 0, 0 left 4, which these are counting by 2's here, left 4 and down 3, we would get to this point negative 4, negative 3. So it turns out that B is the graph of number 15. And you can deduct there that C is for number 16, but I'll leave that one for you to look at. Now, the next part is to find out from these tables how the graph of y2 relates to the y1. And we're actually even told specifically what we need to look for. y2 is defined as y1 plus k for some real number k. So based on the table shown, what is the value of k? So let's look at number 28. So I'm looking at how do the y values compare to each other. And it's hard to see with this. You may have to refer to your book, and this is on page 109 in your textbook. But we're going from negative 3 to negative 5, 2 to 0, 5 to 3, 6 to 4. Every value in y2 is y1 reduced by 2 units. And so in this problem, our value of k is negative 2. In other words, y2 is y1 shifted down 2 units. Now, the next section is to use translations of one of the basic functions to sketch the graph of y is equal to f of x by hand. Okay, you certainly could plug all of these into the calculator, but you're going to, I don't know, you're not going to have the pleasure of doing it by hand, I guess. You're going to rob yourself of that opportunity. So let's just take a look at a few of these and to see how this would go by hand. Again, it's critical that you know the graph of these basic functions. We talked about those in the last section, so you have to know those. So let's look at number 40. Y is equal to x minus 4 squared minus 4. Well, what is our basic function? Our basic function is y is equal to x squared. Well, if you remember some key points on that, and if you have graph paper, I didn't paste some in here, it would really be helpful. We know that 0, 0 is on the graph, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. Now, what does this new function say to do? We're going to sketch the graph of y is equal to x minus 4 squared minus 4. So we have to know how this function transforms the basic function. Well, we have an inner change and an outer change, so we have a combination of horizontal and vertical shifts. Well, the horizontal shift comes from the inside change. So remember that x minus 4 inside is going to shift it. Do you remember? Yeah, right 4. And the outside change is going to do the vertical change, and it is going to be down 4. So what we have to do is increase every value of x by 4. So x is going to increase by 4. Right, that's what happens when we move to the right. We get larger in the x direction. And down 4. To go down by 4 means the y values are going to decrease by 4. Okay? You can do that either counting, or you can actually do it algebraically. Like if I wanted to increase my x by 4, decrease my y by 4. Increase x by 4, decrease 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 y by 4. So whenever we go to the new graph, what's going to happen let's start with our vertex point. 0, 0 is now going to become 4, negative 4. Right 4 and down 4. 1, 1 is going to become 5, negative 3. Right, because we're at 1, 1 and we're going over 4, down 4. What is 2, 4 going to become? 2, 4 is over 4, down 4, which would be 6, 0. Okay. And then negative 1, 1, to increase the x by 4 is 3. Decreasing the y by 4 is negative 3. So that's going to be at 3, negative 3. And our last point, negative 2, 4, shifted right 4 and down 4 is going to become 2, 0. Okay, so now you can draw the graph of that by connecting those points. And I think it's a little bit more dramatic whenever you have those drawn on the same graph, so you can actually see that translation that's happening. And again, you can check on the calculator, that's no big deal, but I would be expecting you to know how to come up with those new points. Now, the next problem is to, given the graph, sketch it by hand. This is when you can't enter into the calculator, so it's really important that you know the effect of these vertical and horizontal changes. It says to indicate how the 3 points labeled have been translated. So let's just look at one of these, like number 50 for instance. 50 is y is equal to f of x minus 2. Well, we have to know, what does that interchange do? F of x minus 2 means that's going to move f of x. How? right 2 units. Do you remember if it's an in or change, it's the opposite of really the sign that's there. So how would you do that? You have to move every point here right 2 units. So like 5, 0 would become 7, 0. Okay, right 2 units is only affecting the x, not the y. Negative 1, 4, if I move it right 2 units, would become 1, 4. Negative 3, negative 2, right 2 units is negative 1, negative 2. So notice the picture doesn't change. It's just as if somebody picked it up and moved it over 2 units. Okay? Again, that should be a straight line right there. Use your imagination. I promise I can do this one. It's paper and pencil. Okay, so I want you to take each point through the translation and see what would happen. And I'll leave those others for you to look at. These are a few problems from my math lab. Number 12, the function y2 is defined as y1 plus k. We actually saw this problem earlier with the tables, but just looking at it from a different perspective. So it's based on the graphs of y1 and y2, what is the value of k? So y2 is y1 plus some number. Well, it tells us that 6, 2 is on the graph of y1 and 6, 5 is on the graph of y2. So since we know that it's y1 plus k, we know there is, and we can see that clearly here, a vertical shift. And how did the original function get shifted? It was up 3 units, right? So y2 is really y1 plus 3, so therefore k is 3. Number 13 in my math lab, suppose that h and k are both positive numbers. Match the equation with the graph. I suggest here you actually plug in some numbers just to get a feel for it, though this is not a precise answer here. Let's just say we're looking at y is equal to x plus 5 squared minus 2, okay? Because I've chosen a positive value for h and a positive value for k. What would happen here? This would be a shifting. Really, the direction is what we need to know. If I have a plus inside, that's going to move it to the left, right? And a negative on the outside is going to move it down. Well, think about what's your basic function and what you're moving left and down. Our basic function is a parabola. Look at one of your key points, which is the origin. Well, it is the origin, but it's a vertex point, which is 0, 0. Well, and if we have to move that left and down, where are we going to wind up? Yeah, in quadrant 3. So what we're looking for now is a vertex that is in the third quadrant. And here it is. So B would be our answer. Okay. And the last problem, number 18, is given us a linear equation that is the approximation for the annual cost for tuition and fees at private universities, where x equals 0 corresponds to, x equals 1 corresponds to 1988, x equals 2 is 1989, and so on. We want to write an equation that yields the same y values when the exact year is entered. Okay, so right now, what are we entering for x? X is the years after 1987. So right now, if we wanted to enter 1987, we wouldn't enter the year, we would enter x equals 0. Well, what this problem is asking us to do is actually to enter the exact year, that is 1987. So we're changing the meaning of x, we're wanting it to become the exact year. Well, to do that, we're making a shift in the right direction, right? We're actually changing the value of 0 by shifting it right 1987 units. So to shift it right means that the x function or x variable has to be changed in some way. And a shift right is going to look like f of x minus c. So what we would have to do is insert x minus 1987 into our function x, or in place of x, to get the desired result. Okay, So that concludes this section on horizontal and vertical shifts. Please contact me if you have any questions. Thanks so much.